Saxon Algebra 2, Lesson 38, we have, it's really kind of one, I guess it's two, but it's all algebra, it's straightforward, it's not as long as that whole chemical compounds adventure we went on yesterday. Let's dive in. The first topic is called powers of sums, and this is a dirty trick that algebra pulls on us. Let's say that we have an expression like this, x squared, y squared, and we want to raise it to the power of 2. Okay, we know we've got a rule for that, right? That if you're raising a base with a power to a higher power, then you just multiply the exponents, right? That's great. So we're going to do that. We have to do it twice because we technically have 2 bases, right? So that will become x to the 4th, y to the 4th is our answer, right? Yay, that's correct. But what if we do one tiny change to that? All I'm doing is I'm putting in, oh, and I want to square it, just like I did before. This plus sign causes drama. Terrible drama. Because here's the thing. There's no power. We cannot use the power rule on this because of that plus sign. Notice here, it's only when we're multiplying bases. There's no adding allowed in these situations. So the only thing that we can do when we have this is we have to multiply it out like a pair of binomials. We have to do the dance, so to speak, right? You know my whole thing about the kids in the dance studio shuffling around on Saturday morning. We have to do it the long way. We have to multiply as binomials. And that's kind of heartbreaking because it would be so, this is so easy, right? But this is kind of a pain and you have to go over to the side of your page and multiply it all out. You know how to do it. I'm not going to show you how to do it, but I want you to recognize that when we're taking the power of a sum, that's what the plus sign refers to, we have to do it the hard way. We have to multiply it out as binomials. And that's just the way it is, and there's nothing we can do about it. So let's look at our first example. It says, expand. And look, it's to the 3rd power. Oh, that means we have to multiply it 3 times. So here's what we do. X plus 3 times x plus 3. This will be the first and the second time we multiply, right? The first and the second sets of binomials we're going to multiply. Then we'll get this answer. Then we'll have to multiply it one more time by a 3rd x plus 3 to get all 3 of them. Okay, ready? X squared plus 3x plus 3x plus 9. We add that all up and we get x squared plus 6x plus 9. Here, I'll just slide it up so you can see that better before I move on. Because then what I'm going to do is I'm going to bring that over here and I'm going to write it again, x squared plus 6x plus 9, and then we're going to multiply it one more time times x plus 3. That'll be our 3rd one, right? So 1, 2, 3 times because we wanted it to the 3rd power. All right, so now we just do the whole dance thing over again. X cubed plus 6x squared plus 9x. And then she's done and it's her turn. Plus 3x squared plus 18x plus 3 times 9 is 27. And I just barely have room to squish this all, but our final step is to add those all together. And it will be x cubed plus 9x squared plus 27x plus 27. Final answer. Okay? It's not hard per se, but it involves doing the dance and it gets complicated. And don't you just wish it could be x cubed plus 27? But we can't do that. We can't just cube each piece. We have to multiply it all the way through. Okay, now we're gonna move on to the next topic. Dun, dun, dun. This topic is called solving by factoring. And I believe this is review. I'll explain as we go. Solve. And John gives us a muddled up equation. Okay? This is not what we want to see. That's a hot mess. What we want to see is descending order of variables, everybody on the left, 0 on the right. All right? Okay, so let's start. Let's put this one first. X squared, then we'll have the minus x. Then we need to bring the 6 over. We know that when we change sides, we change sign, so that will become a minus 6, and then we'll have 0. So that was step 1, is fix it, right? Now, John's going to be nice to us in the starting, and he's going to let us factor by inspection. I like to think it was observation, which makes sense too, but anyway. Okay, so we're looking for 2 numbers that multiply to this and add to that. I'll give you a second to think. And we realize the numbers are x minus 3, x plus 2. Okay, we've been doing this for a long time, but now we're going to actually solve to find out what x is. And we need to know something called the zero factor theorem. Whenever you see the word theorem, I want you to go, oh, here comes something that's obvious but important, and we need to write it down. And here's what the zero factor theorem says. If m times n, just random letters, equals 0, then either m equals 0 or n equals 0. You know what I'm saying? If the answer is 0, then one of the 2 products has to be 0, because that's the only way you can get 0 as the answer. Just think of learning your multiplication tables, right? If anything you multiply by 0 equals 0, but there's no way to get 0 as the answer unless one of the things you're multiplying is 0. So we're going to use this to our avail, because if you look at it, we're saying that these 2 things multiply together equals 0. So that's just like this. So either x minus 3 equals 0, or, and you can write the little or if you like, x plus 2 equals 0. This quantity equals 0, or that one. One of that's got to be true. And then we can just quickly solve these, right? Just add 3 to both sides. And we get x equals 3, or, and here we subtract 2, x equals minus 2. And the way we often, this is fine with me if you just box your answer like this. Or a lot of times people will write x equals 3, comma, minus 2. That's nice too. Either one of these presentations is fine with me, all right? But we use the zero factor theorem to say, all right, if we're multiplying these 2 chunks together and they equal 0, then either this one's 0 or that one's 0, and then we solve. So zero factor theorem, which is also sometimes called the zero product theorem, but it's the same idea. Okay, let's do another one, because that was fun, right? 38.3. All right, solve. All right, I don't like the looks of this. There's a cubed, there's a squared, and there's a plain x. That's too many x's. I don't like it. I don't like it one little bit. So what I'm gonna do is I'm going to bring them all over here to the left and take a good hard look at them. I'm gonna write them in order, always descending variables, right? So this one's gonna be first. I change sides so it becomes positive. Then I bring this one over. It changes sides so it becomes positive, right? Because it's opposite. And then this minus is gonna stay the same because he's already where I want. And this equals 0. Now, like I said, I still don't like it because it's still, there's one too many x's in each term, and I realize, oh, there's actually a simple solution for that. I'll factor out an x from each term. X squared plus 2x minus 35 equals 0. Oh, this looks so much better, doesn't it? I like that a lot. So what I'm going to do is I'm just going to leave the x on the outside, but I'm going to break this down into a pair of binomials by inspection. Two numbers that multiply to minus 35 and add to plus 2. I'll give you a minute to think of them, and then I'll write them down. I know there's going to be one minus and one plus. I know it's 7 and 5 because the difference is 2. The bigger number should be positive because then the total ends up being positive. All right, beautiful. So now we're factored, and now we're going to do the same thing, except notice that this time we have 1, 2, 3 factors. It doesn't change anything. It means either the first one is 0, the second one is 0, or the third one is 0. So we set it up. Either x equals 0, x minus 5 equals 0, or x plus 7 equals 0. If you like to write the little ors in there, I found that some students in the beginning like that because it helps them kind of make sense of it, but you don't need to do it. This is a final answer. This will become x equals 5, right? I just changed sides, change signs, and this would be x equals minus 7. Again, this is a perfectly fine way to show your answer, but it's also fine to write them all together. X equals 0, 5, and negative 7. And this is correct. Beautiful. Now, one last point for the road here is that in this case, we factored out an x, didn't we? Right? There were too many x's in here. And it makes perfect sense to say either this one is 0, this one is 0, this one is 0. We saw that we got these 3 answers. And this makes perfect sense. This is a reasonable, logical answer, right? But sometimes when we factor out, things look just a little bit different. And let me show you an example. Let's say that we have, and this isn't a proper example. I don't know why John didn't make it one. I wish he would have, but he didn't. Let's say we have this, and we realize, shoot, there's a problem with this because we can't have a number in front of our x squared term. Later we'll learn how to do that. But for now, we don't know how to do that. We don't want to deal with it. But we realize, oh, what if we factored 2 out? I don't want to divide them. I want to factor it out. Okay, so what I'm going to do is pull the 2 to the side, and then I'll have x squared plus 2x minus 35, right? Equals 0. This is the same thing as we had last time. So we know exactly how to factor it. The 2 stays on the outside, and then we have x plus 7x minus 5. And I did that fast because we just did that in the last problem. Now, if we go to do our zero factor theorem work here, then we would say that either one of those 3 pieces could be equal to 0. There are possibly could be. So I'm going to forget this one for just at the beginning. Either x plus 7 equals 0 or x minus 5 equals 0. And again, we can quickly solve those. X equals minus 7, x equals 5. But what about this first one? 2, according to our logic, we say 2 equals 0. Because this is the third factor, right? So is it possible that that is equal to 0? But this makes no sense, right? 2 equals 0 makes no sense. So what we say here is that this is no solution. And what I like to do, if you had this problem on a test, what I would want to do is I would want to see you draw boxes around all 3 of these. And then I would want to see you cross that one off. Writing no solution is nice, but, or this part is not a solution. That's probably a better way to say it, not a solution. Because we do have solutions, they're over here. And the final answer would be x equals minus 7 or 5. So when you factor out a number, it doesn't give you another solution. But when we factor out a letter, then we do have a third solution. And a good way to remember that is, in these problems, we will have as many solutions as the highest exponent on x's. So in this one, we had x to the cubed, x cubed, and we had 1, 2, 3 solutions. Over here, notice that even though we had this wonky equation, our highest exponent was just a 2. And that's what we have as 2 solutions. So that exponent can give you a clue as to how many viable solutions you should find. When you factor out a number, it does not give you a new solution. Beautiful. All right, homework. For lesson 38, I want you to do all the practice, and then I want you to do problem set. Let me just take a quick peek. I want you to do problems 7, 9, and then 15 through 29 odds. Okay, so these two, because these are from this latest lesson, so I want you to practice those. So this would be 15, 17, 19, 21, 23, 25, 27, 29. Odds only in this range, plus those two. All right, happy Thanksgiving. I'll see you for lesson 39 another time. Goodbye.